Hi students, welcome to the show. Today in chemistry we are going to be looking at hybridization. In hybridization, the last lesson I made a video on hybridization and I was able to explain little things about the hybridization of water, methane and propane. Don't forget that is for the student in higher institution. So let me come to the level of the students in the secondary school. The hybridization, don't forget my former definition still stands, that hybridization is a process whereby an atom is being mixed together to form an hybridized orbital. Now, let's say we have magnesium. If you want to draw the hybridization of magnesium, you understand? That is how the electrons are being arranged in the orbital of magnesium. Now, you start by identifying the atomic number of the element. The atomic number of magnesium is 12. So, the electronic configuration will be 2, 8, 2. Isn't it? 2 plus 8 is 10, then that's 12. Now, the next thing you are going to do is to state the orbital configuration. What did I say? Orbital configuration. And that is to say 1s, 2s, 2p. Now, the 1s can accommodate the maximum of 2 electrons. We have 2. 2s can accommodate the maximum of 2 electrons. That is 2 plus 2, 4. Remaining how many? Remaining, deduct 4 from 12, the remaining 8. The maximum electron that p orbital can accommodate is 6 electrons. So we have 6. So 6 plus 4 will give us 10, remaining 2. So this is 1s, 2s, 2p, isn't it? Then the next will be, that is 2p senior prefect. So the next will be 3s, isn't it? 3s. Now, 2 plus 2, 4, plus 6, 10, then 2. This is called orbital configuration. This is called electronic configuration. Don't forget, they are not the same. This is electronic configuration. This is orbital configuration. Now we are going to do the hybridization. I'm going to show you the hybridization of this element, which is magnesium. Let's see. Now you see this one is having 2 electrons for 1s. We have 2 electrons, 1 up, 1 down. They are paired. 2s, you see we have 2 electrons. They are paired. Now the p6, they have 3 types of orbitals. We have the px, py and pz. So we have 2px, 2py, 2pz. For this, you are going to arrange it. How? 1, 1, 1. Then you start from here. 4, 5, 6. You see we have 6, isn't it? Then the last for this element, the last orbital for this element is 3s, which is having 2 electrons. So you now have, so that means for the 3s, we have 2 electrons, which will be like this. So now if you are asked to write the orbital, the hybridization of magnesium, so this is what you are expected to write. This is what you are expected to write, isn't it? This is 1s, this is 2s, this is 2p, and this is 3s. So you can try for the remaining elements in the periodic table so that you get yourself on the track. You understand? So this is example 1. This is example 1. let's take ammonia. Take the hybridization of ammonia. In the hybridization of ammonia, you are going to start with the nitrogen, because nitrogen is the one that is gaining 3 molecules of hydrogen. You understand? So definitely you are taking the atom of nitrogen from ammonia. Now what you are going to do is, don't forget that in a normal structure of ammonia is supposed to have, nitrogen is supposed to have the atomic number of 7, isn't it? Nitrogen is 7, while oxygen is 8. Now we are supposed to have the electronic configuration of nitrogen to be 2, 5, isn't it? We are supposed to have 2, 5. Now, if you draw the orbital configuration, you are going to have 1s2, 2s2, remaining how many? 2p, 2 plus 2, 4, plus 3, 7, isn't it? 7. Now, but for hybridization, you are going to omit this one. You are going to omit that one. You are going to add this together. And that is what will now give you the hybridization of ammonia. Now, this one here now, we have 2s, isn't it? And we have 2s. Okay, now, so we are going to omit the orbital of 1s2 and combine 2s2 orbital and the 2p. So that 2s and 2p orbitals will be jointed together, and that is what we refer to as the sp3. Now, we have sp, we have sp2, we have sp3. You see, this sp is mainly for alkyne, that is triple bond compound. You see, sp2 is mainly for double bond compound, alkane. Then you see this sp3 is mainly for single bond, that is alkane. You understand? Or compound that has single bond. You get it? So now, if you combine this together, how do we combine it together? This one is 2s, which is 2s2, 2p3, isn't it, from here? Now, this is paired. This one is 1 unpaired, 1 unpaired, 1 unpaired. So you are going to join them together. When you join them together, you are going to have, this is double, that is paired. This is single, 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 that is unpaired, unpaired. So we call it sp3 because they are all single bond. Now, what you are now going to do in drawing your structure now is, you see here we have double bond, that is paired electron. You are going to write your nitrogen is having double bond, these two. How many unpaired bond? This one will now be for hydrogen, which is 3. So you have 1 hydrogen here, 1 hydrogen here, and 1 hydrogen here. So you have your hydrogen, you have your hydrogen, you have your hydrogen. So this is ammonia, and this is the hybridization of ammonia. Thanks for watching.